I can rotate.
Because like, it's an agile thing. Like, there is no discrimination.
Oh, fuck, I actually
Yeah. You may be considered like the lost tribe, but
What's sport first?
yeah, I think they're concurrent.
I should put my camera and my tripod.
You don't have to hold it all at once.
Hey, how are you? Good. Trying to stay.
Hi, Sabrina. It's good to see you again. It was really brief when I saw you.
How are you?
Okay,
Is it
yeah.
on? Wait, fix your strap. It's like hangover thing. Yeah.
This is a message for all CS61A students.
Okay, so you're gonna go home for spring break now.
So midterm 2 is happening tomorrow at 8 to 10 p.m. I too used to be a CS61A student, so I went through a whole lot of stress during this midterm season.
7 to 9.
Oh, 7 to 9. It's not 8 to 10. But I too used to go through a lot of stress taking CS61A. So in an attempt to help ease your guys' stress, I've come up with a very short rundown of the big topics that you should know for the second midterm of CS61A. Okay, louder again.
Just a bit louder.
So, oh god. So you can see on the blackboard, I've written 8 or 9 large topics that you should know for the second midterm. The ones that I've checked off in red are the ones that you absolutely should know because they will play a huge part in the midterm tomorrow. Be sure that you guys know all of these topics in and out by the end of today. So I'm just gonna go down them one by one, give like a short rundown, and for some of them, there's a lot of edge cases and weird cases that probably will turn up on the midterm, so I'll go over some examples for that. So the first one is sequences and lists. So this is a very important because it's like a basic data structure that becomes very important in future applications throughout the rest of your career in CS. One of the most important tools is splicing. And basically what splicing is, it's creating a copy of the list, specifically if you want to have a very, if you want to have like a brief section of the list, not the entire list, then you can use splicing as a way to get that list without actually having to use it. So the general structure for splicing is basically square brackets, and then you include the start index as the first element, and then the end index as the second element, and then optionally you can also include the step as the third element. That is optional. If you don't include it, that is fine. What is important is that you have to include the colon in the splicing. If you don't have a colon, then it will error out and it will act as if you're actually trying to get an element from the array. So I'm just gonna go over some examples for splicing because I think it's really tricky, especially in the final, it'll come up again. So right here you see A, 2, 4. The start index is inclusive, the end index is exclusive. So as you can see here, the A is a list 3, 1, 4, 2, 5, 3. And then in green, very small, I have written the indices. Oh, okay. Okay, so A24 gives you the list 4, 2, because if you look, you start at the index 2. The third element is 4, and then the fourth index is 2. So it goes 4, 2. You don't actually include the fourth index, so the fourth index is 5, so you don't actually include it. So all you have is 4, 2. If you go from 4 to 2, then you get an empty list because, remember, this is also important, splicing never gives you an error. So if you do something weird with splicing, the worst you can get is an empty list. You don't actually get like some error that causes your code to not run. So for 2, it's actually impossible to do that, so you get an empty list. Now, if you go from 1 to -2, there's this really weird thing with splicing, which is that there's indices, positive indices from 0 to the length, but there's also negative indices. So if you start at the very end, that's indices, this index is -1, -2, and then counting all the way back is -6. So if you go from 1 to -2, you'll see right here, -2 is actually 5, 1 is still 1, so you still get 1, 4, 2. You don't actually include the last one, so you get 1, 4, 2 as your list. If you don't include the start index and the end index, it's automatically assumed that the start index is 0, the end index is the length of the list. So if you do A and then just a colon without including the starting index and the ending index, all you get is the list back itself. You basically just make a copy of the list. before this, we weren't using steps. Now we're going to use steps. So if you don't include the start and the end index, the step is -1. So what you end up doing is you reverse the list. Now, if you go from 1 to 4 and you step -1, that's actually impossible because you want your step to be positive, but it's actually negative, so you get an empty list as a result. But if you go from 4 to 1 with a negative step, then you actually go down and you actually get 5, 4, going from the index 4 and then go down to index 2. One last thing with splicing is that when you splice out of bounds, it can either give you an empty list or the entire list. So if you look right here, if I splice from -70 to 70, because -70 is less than the starting index and 70 is greater than the ending index, what you get is the entire list itself. However, if you do from 70 to 72, that's completely out of bounds. The starting index is already greater than the actual end index of the list, so you get an empty list as a result of the splicing. Okay, so that's pretty much it for splicing. In addition to splicing, for lists, you should know what mutative methods are and non-mutative methods are. So the mutative methods are like the main ones: append, extend. Those you should all know. Remember that append takes in an element, and extend takes in a list, and actually appends each of those elements of the list to the list that you're extending to. I'm gonna skip any versus all. Okay. The second big thing that you should know for the midterm is equality. This won't actually be a huge thing, but you should just know because it's a good thing to have in your mind for future classes and stuff like that. Usually you use is or equals as a way to check for comparing between two different variables. For things that are only one element, so excluding lists, dictionaries, that stuff, is and equals pretty much do the same thing. However, if you're like comparing two lists or comparing two dictionaries, if you do is, you're actually checking for the that the references are equal. But if you check equals, you're checking that the individual elements of the lists are equal. So, for example, if list one is equal to 1, 2, 3, and list 2 is equal to 1, 2, 3, list 1 is equals list 2, but list 1 is not list 2. List 1 is list 2 would return false. Third is list comprehension. I won't really be going over this because the general structure is pretty simple. All you got to do is make sure that you know it in and out. You'll probably be using it a lot in your questions for like trees and linked lists and that kind of stuff. For this trees, the tough thing about trees is that you have to know the general structure of how to iterate through a tree, and once you know that, most of the questions will become pretty simple. So the general structure is a recursive structure. You start at the top and you check if the node is like, you check the base case, and usually the base case is leaf. At that point you would terminate and then stop the method. However, if that's not the case, what you want to do is you want to iterate through the branches, and usually you do this with list comprehension, and you do a recursive call within. So that's the general structure for iterating through a tree. Really, the only way you can get better at this is doing a lot of practice, so I would recommend going over past midterms and stuff like that. Fifth is non-locals. Non-locals is a key word used to modify variables that are outside of your current frame. It is important to know that in order to modify, you need non-local, but if you only want to access, you don't need non-local. You can already access variables outside of your current frame. Modifying is the only thing that requires non-local. The general rule of non-local is that you start with the parent frame, that's the innermost, and then if you can't find it there, then you go outer and outer. There's also one exception with non-local, which is that you can't modify variables in the global frame with non-local. So for example, if in the global frame, you declare a variable x, but within a frame, in the global frame, F1 for example, you try to say non-local x, that's actually not allowed. You won't be able to modify x because x is in the global frame. 6 is object-oriented programming. Now this is super essential because you'll probably be taking CS61B and other classes in the future, and all of these classes use languages that require object-oriented programming, and Python turns out to be one of them. The general thinking for object-oriented programming is that it involves a paradigm of something known as objects, which are basically a collection of attributes and methods and variables. There are two levels when it comes to object-oriented programming. The first one is the class level, and the second one is the instance level. So for example, there can be a class called human, and then an instance of human would probably be Reese Gillenheimer or something like that. So that's an instance of human, so it's important to distinguish between the two levels and know when you modify a class variable, you're actually modifying the variable for every single instance, whereas if you modify just the instance variable, you're only modifying the variable for that instance. So I've come up with an example over here. You see that we have a class car. We have a class car. It has two class variables, headlights and size. However, within the constructor method, you can tell if it's a constructor method because it says init and init. And then within the constructor method, there are two variables, and those two variables are known as instance variables, which means they are special and only for that instance. So for example, if you create a new car, so right here, r equals car, then it has the attribute headlights and size, and it has two headlights and it's small, and in addition, you'll have a model of whatever, and it'll have a color. However, if you call the paint method, what paint does is that it modifies the instance attribute. So here, you'll see the self.color equals color. So if you call paint black, then R will be black, but car itself, it doesn't have a color attribute. So cars as a class, as a whole, will not have color, but that instance of the car will have a color. Let's say, for example, you try to enlarge R now, but you'll see that in the enlarge method, you're actually modifying car.size. So you're modifying the class variable or the class attribute. So if that's the case, what happens is that not only will the size of R be modified, the size of every single car instance will also be modified. So that's the difference between instance and class. There's also a lot of weird cases where you use repr and str as a way to display objects, display classes. The general rule of thumb is that when you call repr and str explicitly, you add quotation marks, but when you call it implicitly, you don't actually have the quotation marks. So if you see right here, if you call repr of the string 1, 2, you'll see that you actually add quotation marks. So the, you get quotation mark, 1, 2, end quotation, end quotation. However, if you call it, like, if you call just R, for example, and you're implicitly calling the repr method, you don't actually add quotations, you only get small, but when you explicitly call it, you get small with quotation marks. The same thing can be said for str. What str basically is that you take whatever, so for example, if you do str of the string 1, 2, basically what you're doing is you're calling print 1, 2, and then taking whatever that outputs and adding quotation marks to it. So you'll see right here, str of 1, 2 gives you quotation mark as a 1, 2 quotation mark. However, if you do print of 1, 2, that only gives you 1, 2, because you're calling str implicitly.
That's cool. That's a home.
So I'm going to just briefly go over the last few because they are important, but the thing is, there's really nothing you can do but like just do practice problems with them. So the first and most important one is linked lists. Just know what the first attribute is, the rest attribute is. If you want to reference an empty linked list, do capital L link.empty. I ran into a lot of problems with students having a lowercase l because it was an instance attribute, but it's actually empty as a class attribute. You want a capital L on empty, all right? This is super important because if on the exam, if you do a lowercase l, you will get points off.
That's right. Gotta be capital L.
What's also important is the use of dictionaries. There's honestly not going to be that much about dictionaries on the exam, mainly because you'll probably be focusing mostly on linked lists and trees, but it's also important to know dictionaries. The way dictionaries are structured are key colon value, key colon value. Key can be pretty much any immutable type, and value can be any type. In addition, within the same list, like keys can be multiple different data types, so you can have within the same dictionary, for example, the first key can be like the number 1, and then the second key can be the string 1, 2, or car, or whatever you want. And this also holds true for values. They can be multiple different data types within the same dictionary. One super weird thing with dictionaries is that if you want to get the values or if you want to get the keys of a dictionary, usually what people tell you to do is you want to do dict.values and then parentheses. But what this actually gives you is that it gives you a view of the list. It doesn't actually give you the list. This is highly problematic. Because what you can do with a view is that you can iterate through a view. You can get the length of a view. You can check if an element is in the view. But if you try to actually get the element, for example, you set something equal to dict.values, and you like, for example, you set list equals to dict.values, then if you try to get list of the list square bracket to n square bracket, that gives you an error because that's a view, that's not actually a list. What you need to do is that you need to convert the view to a list, and the way you do that is you call the list method. Oh, by the way, feel free to take pictures of these boards. I spent a lot of time on these last night. I don't want them to go to waste, so if you feel like this will help you, feel free to come up, take a picture. Just make sure that you're not blocking anybody else. And finally, the last important thing to know is orders of growth. Once again, this will be a pretty minor topic in the CS midterm, mainly because you kind of brushed over it, and you'll definitely go over it a lot more in CS 61B. But the important thing to know for orders of growth is that there are two main summation formulas that you should know. I wrote the two main summation formulas down here, but honestly, you can just search them up. It's probably on your discussion. I would highly recommend putting these on your cheat sheet because it's sometimes hard to memorize things, and cheat sheets help. It's right here. Okay, so that's pretty much it for the main topics. I went over 9 main topics. The most important ones, as I checked, are splicing, knowing what the mutative methods are, list comprehension, trees, non-locals, class versus instances in the object-oriented programming, linked lists as well. So that's pretty much the most important things that you should know. Before I close, I just want to leave you with some important tips that you should know. The first one is that you want to draw environment diagrams as much as possible. This is super helpful for when you're trying to keep track of non-local or object-oriented programming. So for example, the what would Python do? Everybody knows those are pretty bad, and nobody in real industry would actually do that. But the thing is, with environment diagrams, everything becomes so easy, you know? So easy. You just gotta draw environment diagrams. That's all you gotta do. And in addition, the second tip is that you want to memorize the general forms, or at least write the general forms of methods onto your cheat sheet. So the two most important general forms that I would say are iterating through a tree, which I went through before, and also iterating through a linked list. And finally, the most important thing is to use your cheat sheet.
Yes, use your cheat sheet, everyone.
You won't believe like how helpful your cheat sheet actually is. You'll think that, Professor De Niro will probably be giving me cheat sheets and that'll be helpful.
No,
but the fact
they're useless.
No, I mean, they are pretty useless, but like the fact that you writing down things that you don't know and will like ingrain it into your mind, so that just the mere act of making a cheat sheet will help you study for this midterm. And cheat sheets are especially like useful for like memorizing the mutative list methods and pretty much anything that you think that you need to review. Last semester, even though like I still had space on my cheat sheet, what I did was I literally took past midterm solutions and then copied the solutions onto my cheat sheet as a source of inspiration. I've also had friends who write like inspirational messages on their cheat sheet. You know, you never know if you need that confidence boost halfway through that midterm.
You're smart.
Yeah,
loyal.
Yeah.
I appreciate you.
So that's pretty much it for my review of CS61A midterm 2. Once again, feel free to take pictures. These resources are free. Just completely free, so you can take pictures and whatever you want. So thank you everybody for listening.
Yes.
Yes. Okay. All right. Oh my God. Dude, good job, man.